Good afternoon, everybody. My name is Derek Atkins. I'm the Chief Technology Officer at Verify Security. And today I'm going to be talking with you about making buildings and industrial IoT cyber safe, and a little bit about the Verify Dome solution and how we use that to protect. So a little bit about Verify Security. Verify has been around for over 15 years now. We have our history starts with being able to secure very, very small devices. We used various cryptographic methods to secure very, very tiny devices, even going down to RFID. We've won a bunch of awards along the way, and we have a bunch of partners along the way as well. But recently we've shifted focus and moved more into taking that knowledge of securing small devices and looking at places where there are small devices that need protection, and that's where we've landed in securing these types of networks that we would talk about today. Now, in general, we can focus on anything from industrial and operational networks. I'll talk about that in a second. Just want to point out right now, if you've read any newspapers or magazine articles in the last couple of years, I'm sure you've seen headlines like these where hackers are targeting buildings. And they're not targeting buildings by coming in through the internet, they're targeting buildings by coming in through their operational networks. So for example, there was a big story about how a hacker was able to get into a casino by going in through a smart aquarium. And the Wall Street Journal had a great article about why hackers love smart buildings. And I'll explain why these are happening. But more and more are, you're seeing more and more of this, where operational networks and informational networks are combining, and it's growing the attack surface. But let's take a step back. I bring up these terms: operational networks, information networks, IT networks, OT networks. What does that all mean? So let's talk about IT networks, information technology networks. These are the networks that run your business. These are the networks that most people think about when you think about networking. These are the networks that are running your HR systems, they're running your payroll services, they're running your websites, they're running your email and file transfers. Generally, these systems run on very, very large servers. They run on the cloud, they run on your laptops, they run on desktop servers. I'd even call your cell phone part of your IT network. So these technologies have been around a very, very long time. Security has been up and coming for decades. These days, when you go from your laptop to your bank, it's all protected, in very good terms, and people are attacking it in very different ways. Let's contrast that to your operational networks. Operational or OT networks, these are things that run your infrastructure. These are your building networks. These are your machine networks. They're networks that control and manage your interfaces to the real world things. A difference is these are generally running on very small embedded devices. They're not running on laptops and servers, they're running on tiny little things, a thermostat, a device controller, a PLC. And one thing we've found is that the technology of OT networks, and specifically the security of OT networks, is often 20 years behind IT. So if you think about where IT and internet security was 20 years ago, that's approximately where these OT networks are today. So there's some examples of OT networks that are affected by this dichotomy. In your building infrastructure, you have your HVAC systems, security, safety, lighting. All these types of networks are running on these technologies, some of it using IP, TCP/IP, the same networking layer that's done on your computers and on the internet, but specifically for buildings. You also have OT networks in industrial networks, SCADA networks, control systems, utilities. These are a lot of examples of OT networks that are controlling everyday lives. I mean, our lives would not work as they do today without these OT networks existing. So here's a typical IT OT network combination. And unfortunately, I don't think you can see my mouse pointer. So I'm going to have to describe where we're talking. So at the top, we have the internet that comes into your IT router, a gateway. And this is how your building or your network connects up to the world. And from there, it goes into a network switch for your IT network. And then you have a bunch of other switches and devices that are sitting on your IT network. And then we get into your OT workstation. So you'd have a workstation that's managing your operational network. And that goes down to an operational network switch, which has a bunch of devices and routers and other things talking to it. And then you can even go off of TCP/IP into a router that's going to convert from IP to EIA 45. That's going to be something like a Modbus or an MSTP or some other potential SCADA protocol that goes to a bunch of devices that are sitting there. And that network is open as well. So the only way at this point to protect anything is by firewall rules to protect from one thing to another. But as we all know, firewalls are meant to be broken. So there's a lot of difficulties in securing these OT networks. I should point out one thing before here is that while the issue here is that as the IT networks and OT networks get combined, that opens up the attack surface. Because originally, 20 years ago, that OT network was standalone and by itself, and you had to physically go to the network to do anything. But as things get more connected, you want to have access and visibility, through cloud services. That's where all of these issues are coming into being. So let's now talk about the difficulties in securing these networks. So these OT devices are very, very small. As I mentioned, they're all sitting on embedded hardware, very, very small. They have limited resources. It means small CPU, very, very small, limited flash and RAM capabilities. So you can't put a lot of code on there, and they just can't. They don't operate very efficiently in terms of doing big computations. They're not meant for big computations. They're meant to do one small thing well. Taking a temperature of the room, seeing how fast a device is spinning. Lots of, how open is a valve or how close is it? Another issue is that we have heterogeneous networks. So you have stuff from different manufacturers all in one facility, which means anything that one thing is doing special, you have to go to the least common denominator. So you have to make sure that, when these devices are talking to each other, one special feature of one device might be different than a different special feature on a different device. So if they need to communicate, you can't use those special features. So you can only use the technology that they all speak. And it just makes it harder because you have to talk to all these different manufacturers if you want to secure it. A lot of these devices are dedicated firmware. So they're not necessarily running a real-time operating system. They're not running Linux or anything like that. It's literally just a piece of firmware running directly on the hardware. So that doesn't give you the flexibility to just go add additional services to do things on those devices. They're very dedicated to what they're doing. Another big problem with these OT networks is that a lot of these devices, they don't have firmware update solutions. So once the device is deployed in the field, you can't change it. There's no ability to push a software update like you do on your laptops or your cell phones or your servers. There's nothing, there's no capability to change that code. If there's a bug, there's a bug. And the only way to fix that is either to physically go and touch the device, or more likely pull the device out and replace it with something else. And that's just the way, unfortunately, it has gone. Another issue is that there's no authentication or encryption on OT protocols. They're all wide open. If you have physical access to the wires that are going, that are between these devices, or if you have virtual access to those wires, if you can log into a device on that network or to log into the switch, you have full access to that. You can see everything going across, but even worse, you can inject traffic into that network and cause these devices to do things that they're not supposed to be doing. And as I mentioned earlier, the biggest concern here is that that attack surface keeps on expanding and growing as your IT networks and your OT networks get connected. And the more these networks get connected, the bigger the attack surface is, because now you have a connection that you might not have known was there before. So going back to that picture that we had before, here's a pointers to a bunch of different threats that exist on this IT-OT network combination. So starting at the top, you can have a bad actor that gains access through the internet. Again, usually there's a firewall there, but firewalls are meant to be broken. There's ways to get in through, through various means to back channel in through the internet. One possibility for that happening would be another computer on the IT network is compromised. You have someone sitting, in an office, and they click on email and install some malware, and now that machine now becomes a jump point to get access to the network. Someone can phish user credentials. So if I can fake a web page and get you to type in your username and password, I now can then use that to get into your system. Or someone can physically be on, in the device, in the network, in the building, and plug into a network switch. They can go in, get into the closet and plug in, or they can get into a building and get into a wall. And in a building network, for example, they can get to the thermostat and pull a thermostat off the wall and get to the wires behind it. Or in an industrial network, maybe they can get into where a device is and get access to the network. Because everything is completely open, once you have access to any point of the network, you have full access to the whole network. And these are real threats of what can happen. And here's one potential vulnerability. So I'm not going to go into the different vulnerabilities and how you can attack it from each different way, but here's one particular one where you have on the IT side of your network, someone phishes and you have a bad actor who's able to get access to a computer on the IT network. So some user, they do something on the computer incorrectly, they click on a bad link, something gets installed, and someone's able to get access to their computer, and from there they can get access to the IT network. From the IT network, they're then able to gain access to the operational network. Here it's saying a BACnet network. BACnet is a building automation control network, but it could be any kind of network here. It could be it could be KNX, it could be Modbus, it could be any kind of industrial network, because they can get access to it through the IT network because it's all connected. And from there, they can then jump and disable safety or give false readings for some critical piece of equipment by connecting through the OT network and through that router over to the device. And because it's all connected, there's nothing stopping them from doing that because it's all open. So this is why we created Dome. We want to make sure that your OT networks are cyber safe. So at a high level, we're providing real-time cybersecurity protection and device management for your operational networks, for small building networks, and we're doing this in partnership with Intel and AWS. And I'm going to talk about now how Dome can solve this problem. So one thing I want to point out as we're going along is that Dome it's more than monitoring. So one thing what Dome does is the first thing we do is we create a secure zero trust operational network. And what that means is we don't trust anything. If you want to get access to the network, you have to authenticate and prove that you have access to the network. So if you don't, if you're just trying to come in, if you're just trying to send a packet, it doesn't work. Only authorized, authenticated entities are able to join the network and communicate. And basically that's what it's saying. We're requiring all your devices to authenticate to the network and each other. So before they're allowed to communicate, to join the network, they have to authenticate themselves and authenticate to the devices to talk. Once they authenticate to each other, we encrypt all traffic over the network. So what that means is if you're attached into that network switch in the closet, no longer can you see what's going across the network because everything is being encrypted. So some key tenets of Dome that I always want to point out and bring to your attention: identification. So we want to make sure that everything is identified and you know who it is that you're talking to. authentication. So not only do you identify it, I want to prove that I am you, and I'm talking to you, you're talking to me. You want to know who you are. So you know who I am, I know who you are. So that's what authentication is. So you want a device is authenticating to the building or the controller, and the controller is authenticating to the device so that they know that who they're talking to. And beyond that, we also talk about authorization. So not only do you know who you're talking to, but if you're receiving a command from somebody, does that person actually have the credentials to actually send you that command? So, for example, going back to a building, you have a thermostat and an automatic door opener. So we'd have a door lock that can automatically open the door to buzz someone into a building. Well, a thermostat should never be sending a door open command to a door. So a thermostat would not be authorized to send that command. So that's what authorization is. Does the sender of a command have the credentials? Can they do that? Data protection. We want to make sure that every communication that is going across the network is protected by encryption. So you have confidentiality and integrity. So confidentiality means someone who's sitting on the network can't read it. So it's only the intended recipient can read it. And integrity meaning someone can't change it along the way. And as a result, you can't inject traffic either. So someone sitting on the network switch can no longer inject traffic into it. And finally, something that's unique to Dome as opposed to anything else out there is that your OT network devices never need to talk to the internet or any cloud service. Imagine if your thermostat needed to talk to Google Cloud. That in your smart building, or imagine your SCADA device needed to talk to Google Cloud. That would be horrible. That would just open up so many levels of insecurity. So part of the Dome is that your OT devices only talk locally. They only talk on the local network and never directly talk to anything on the cloud. So how do we do this? So here's building up our Dome, talking about the different components. The first one is we have a Dome server. This is the server that manages your device, manages owner authentication, and it does this all in the cloud via blockchain. So this is sort of managing all the controls and gives you access to data and things like that. Now, I mentioned earlier that devices don't talk to the cloud, and that's why we have this Dome interface appliance. So Dome interface appliance is an authenticated piece of software that runs locally on a network that allows and interfaces between all of your OT devices that only talk locally and the Dome server, which is elsewhere, potentially elsewhere. So this is your on-premise service to manage those devices. So this is what separates those devices from the cloud by having this agent on the network. Next, we have our Dome Client SDK. So this is a software development kit, a library that allows an OEM device manufacturer to integrate the Dome services into their devices. So you go to a device manufacturer like someone who's building thermostats, or someone who's building control systems, or someone who's building a SCADA equipment, and we're working with them to integrate Dome into the devices directly. And the Dome client manages device security, manages device provisioning, and it basically manages all the features the Dome platform provides because it's a secure communication platform down to the device. But of course, there's millions of devices that are already out there. There's millions of networks already out there. So that's why we have Dome Sentry. Dome Sentry is a device that's Dome enabled that allows you to retrofit existing operational networks and existing operational devices to a Dome secure network. So you can put a Dome Sentry in front of an existing device, and it acts as a gateway to give it access to that secure OT network. So again, going back to the picture, pointing out where those Dome pieces are added in. On the top left, we have the Dome server, which in this particular picture is sitting on the cloud. On the bottom left, we have our Dome interface appliance, the DIA, and then we have in the middle on the bottom, we have Dome integrated into that router, and of course, we have Dome integrated into all the devices and your OT workstation as well. So now your whole OT network is secured because your OT workstation is talking via authenticated and encrypted communication through the router to each of those devices out on the network. So now even your 485 network is protected. So all your communications on that bottom link are fully encrypted and authenticated to each other. So how does that interact with that vulnerability we talked about earlier? Well, that bad actor is still out there. They're still on that computer on the IT network. However, as soon as they try to get access to that OT data, they're blocked because the data is encrypted and that actor doesn't have the keys. They try to send a command in, they can't because, again, it gets blocked by that router because it has an insecure packet coming in on the secure port and it's going to just drop it. So it gets completely blocked. Great. So what about all those other threats? So again, all those other threats we had before, most of them are blocked. A bad actor that gains access to the internet, again, they don't have the keys to get into that network, so they can't do anything. Again, we just saw that another computer on the IT network is compromised. That gets blocked. Even better, if someone gets access to a network switch, either an IT or OT switch, they can no longer see anything. They can't do anything because all the traffic is encrypted. And best case of all, if someone gets in and pulls that device off the wall and plugs into the wires sitting behind it, again, all the traffic over those wires are encrypted and authenticated. So because they don't have the keys, they can't get in. And because they're not authorized devices, they can't get those keys. So Dome is blocking all these threats to the network. So I mentioned in all those cases before, we had Dome integrated in, but you can go into existing devices and existing networks, existing buildings, existing industrial solutions, and they're there. So you're not going to necessarily go and replace everything that's out there. So we can retrofit existing networks as well with Dome Sentry. So in this particular case, we put Dome Sentry in front of the router, we put a Dome Sentry in front of the workstation, and in this particular case, your 45 network is now open again. So while all of your IP side of the network is protected, we protect against many of those threats still. There's still obviously if someone gets access to a thermostat, they have limited access still, but most of the attacks are going to come in through the internet, through the IT side, and directly through the switch. And in those particular cases, these are still valid attacks that we protect against, even using the Sentry devices. And in fact, we can put Sentry devices on the 45 network as well. We're just not showing that here. It's just because that requires a lot more devices, and some people might not want to do that, but we can certainly do that. So let's take one more step back from Dome. So Dome, as we said, we are talking about the protection, but how do we get to that point? So let's take a step back to the device lifetime and the supply chain process. So when a device is built, it gets a credential from the manufacturer. And what Dome is doing is it's establishing a root of trust in a blockchain for that ownership of that device. So as the device moves through the supply chain, the ownership is managed in a blockchain until eventually it gets to the endpoint and gets deployed. At that deployment side, we have zero-touch onboarding. So this is a process where you literally plug the device in and it figures everything out about where to go and what to do, because it can talk locally to the DIA, and the DIA can authenticate it and authorize it to actually be on the network. This allows you to manage ownership through the supply chain, which gives you a provenance of the device, gives you proof that the device is an authentic device, but the best part is it gives you the ability to authenticate the owner of the device to the device itself. So this device that has no UI at all can come online and know that when it's getting commands to get provisioned, it knows that those commands are actually authentic because they're coming from someone who is authorized to provision the device. And that's something that is unique to Dome. Many cases, you just have a device that's like, I'll take commands from anything. Well, that's not necessarily a good thing. You don't want your printer or your Wi-Fi to be able to just take commands from anybody when it comes online. You want it to only be, you want to make sure that it's only taking commands from you. So Dome ensures that's the case. Dome's main process, how it started, was being able to securely and support security functions in the field. So you want to be able to provision keys and certificates and operational data to these devices in the field. And that's what Dome was originally designed to do through a mutual authentication process and making sure that all your data and commands are protected. So it's a very complicated way of saying that we are managing device from birth to death through the supply chain, and once it gets deployed, making sure that it is controlled and updated and protect your network. So let's summarize some of the features of Dome, just to bring it back again. So first thing is we want to authenticate all your Dome devices and owners using a blockchain. So once the devices get to that endpoint and getting put into your building or put it into your network, we want to make sure that the device is authenticating to its owner and the owner is authenticating to the device. So that gives you mutual authentication. We have an immutable history of who the owner of these devices are, which gives you a lot of interesting ability to do to see who it is and make sure the devices are authentic. So that proof of ownership is your authentication from the owner to the device, and the ownership and the authentication back gives you anti-counterfeiting solution. And basically what this is doing is giving you a secure supply chain, which in some cases it may be overkill in some cases, but many people want this. They want to know that when they're getting a device, that it's actually an authentic device. It hasn't been, hasn't come through some weird thing. And and you can verify how it got to you, which may be important. Again, another feature of Dome is zero-touch provisioning. What this means is, again, you can you take a device, you plug it in, and you don't have to do configuring of the device in the field. You literally can plug it in and it gets configured from the network. There's a lot of benefits to this because it can remove your human errors. So imagine having users having to type in security keys into these devices. Imagine them having to all this work that they have to do to deploy a device. If they have to go and then provision everything in the field, provision anything, who it's going to talk to, who its owner is, what it's supposed to do. There's lots of errors that can get introduced by doing this, and because all this configuration happens behind the scenes, literally it's plug and walk away, the plug and play. This reduces your costs of deployment by reducing deployment time. So where a device may have taken 20 minutes to install before, now it can do it in 1 or 2, and that can reduce the deployment costs. One thing Dome can do is that we can support in-field provisioning and firmware updates. So not only is it provisioned when it comes online, but as it's going beyond, you can change the provisioning of those devices over time by pushing new provisioning out. And because we have the secure platform from coming down from the Dome server through the DIA down to the device, we can actually even push out firmware updates to the devices by enabling that secure delivery of that firmware. And then the device manufacturer can take that and after we validate it and provide to them that secure update package, they can then take that and update their firmware. So now we're enabling these devices to be able to update their firmware as well by integrating into Dome. And finally, we can we can retrofit existing installations. So we know that not everyone is going to replace all their equipment. So the Dome Sentry devices allow you to retrofit and have a mixture of different hardware, different manufacturers, and old and new. So you can have a mixture of, and I'll show some pictures of this in a bit. You can have a mixture of devices that have integrated Dome, devices that have and devices that don't have Dome, and those devices can be from different manufacturers, and they'll all communicate properly. So here's an example deployment for buildings. So a building is one type of operational network. Obviously, there are industrial networks as well, but we're just as an example of an OT network, let's talk about a building. And as an example for buildings, let's talk about BACnet. Here in the United States, BACnet is by far the largest building automation network that's being used. But we know that in Europe, KNX is being used, Modbus is being used. There's many different types of networks. I just want to use this as an example just to get the point across. So this is a example of a building network with Dome. So on the top left, you have your Dome server. On the bottom, you have a Dome Sentry. And that Dome Sentry is sitting in front of some pre-installed devices. Now, above in that middle on the right-hand side, we've got devices that have got Dome inside. So that's OEM products that have Dome support already built in. And these devices are all talking to each other. On the left-hand side, you have the controllers. And on the right, you've got your devices. And on the top, BACnet, there's a new protocol that is being developed called BACnet SC. So using a Dome Sentry, we are able to support future platforms as well, because the sentries themselves can be updated over time, and security gateway, which can combine them all together. So we now have one coherent network, all managed by Dome, where Dome is managing the security of the sentries and the devices, and managing the security of the future protocols as well, all under one control. So again, let's focusing on this BACnet network. This is what happens today. I mentioned at the beginning of this talk that OT networks have no protection, and this is true of BACnet as well. So this is a Wireshark picture. For those of you who haven't used Wireshark, it is a network analyzing tool. So what it does is Wireshark can suck in all of the traffic that's going across the network and display it to you. So what this is showing here is a BACnet network where you are seeing all the traffic. Not only are you seeing which devices are talking to each other because you have your source and destination addresses, but you can actually see what it is that they're saying. So you can see, oh, I'm requesting a property from that device, or even worse, I can see, oh, I am setting a property on the device. I'm setting a thermostat to some temperature. I'm setting a control, to something. I am opening a door. All that is open network and visible to anyone who's seeing it. So here you can actually see what is being seen, what is being sent and read across the network. Great for you, great for a hacker, bad for you. So let's show Dome operation, protecting to the edge. So on this right-hand side, we're now showing what we're capturing across that secure network. And on the left, we're showing that the same traffic that you would see before. But on the right, what's happening is now that it's all protected, all you're still seeing the source and destination addresses, but all you're seeing there is security payload. All the traffic is encrypted. And specifically, when you go down into and open up the traffic pattern, the packet you're seeing, all you see is encrypted data. So now an attacker who is watching the network has no idea what is being sent. They don't even know if it's a request, if it's a response. They don't know, and they can't do anything with it. They can't read it, they can't write it, they can't resend it, because you cannot replay these packets. So an attacker who gains access to the network has no ability to do anything anymore. It completely locks them out of the network. And again, Dome is doing this down to the edge. So we're not protecting just the gateway. We're not protecting just at a firewall. We're going down to the end devices to be able to do this. So as my marketing person is going to have me put a marketing hat on for just a few minutes and say, okay, if you're talking to a building person, but this applies to other things as well. But a lot of these things might be building specific, but the same concepts apply to any kind of target. What's the value that's adding? So if you're talking to a building person, it's going to protect your tenants, your revenue, and your asset values, because you're adding security. You're protecting the people who are in your building. It can increase the building value. There's I'm not sure if it's international or just here in the US. There's a program called LEED, which is an environmental settings for buildings. So environmental standards. So if you have higher LEED environmental controls on your buildings. You know, are you carbon neutral? Do you have low water usage? You know, low power usage, things like that. If you have higher LEED, you can increase the value of your building. Just like if you have higher security, higher cybersecurity, you can increase the value of your building. And people see that as, recognize that as increasing value. For a building owner, it can enhance your lease offering. So if you have two buildings side by side, this one has cyber protection and this one doesn't, the one with cyber protection is going to be more valuable, and a tenant's going to be more interested in being in there. Here in the US, there are various cyber laws that are there to require enhanced cybersecurity. The EU either has or has them coming as well. And by complying with these laws, you can attract more tenants and get more value for your money. Also, this can reduce insurance costs. There are insurance companies that recognize that cybersecurity and the threats of cybersecurity are there. If you have protections in place, they'll reduce your insurance premiums because you're less likely to be a successful target of these attacks. And again, it easily retrofits into your existing buildings, so you don't have to go and replace all your equipment to get these improvements. So summarizing the security of Dome, and again, I'm repeating myself again, but I just want to remind you that some things we're protecting against is that it's protecting against a bad actor getting access through the internet. So someone coming into the internet, you know, we block them. We block access from another computer on the network that's compromised. So just because someone clicks on a bad link, they no longer gain access to they don't have visibility and can't send packets to your OT network. It protects from on-premise access to the IT and OT network. Someone who literally goes in and plugs into the switches, Dome protects against that as well. And protects against on-premise access to an OT device when you have your embedded Dome solution. So stepping back again and looking at potential other people out there that you may hear about, all the cybersecurity products that are currently on the market, what they're doing is they're doing monitor visibility analysis. They are monitoring the network, they're providing visibility into what's going on, and then they're analyzing afterwards. So they're basically reactive to what's going on. They're saying, okay, I'm watching the traffic, and oh, okay, things are going across. This thermostat just sent this message to the door. That didn't happen. Let me go back and raise an alert, because it's basically retroactive monitoring of what's going on. Dome, however, is the first solution to actually be proactive and provide real-time protection and prevention to the edge of an OT network. So by Dome, you can say ahead of time, hey, this thermostat should never be talking to that door, and it gets blocked before it even tries to before that would ever even happen. So we're being proactive about protecting your network, encrypting it, authenticating it, and taking that all the way down to the edge as opposed to just to the gateway. Thank you.